All right, so next we are going to prove by changing the left-hand side until it equals the right-hand side each of these identities. So the first one here, we've got sine of x minus cosine squared of x. So we're going to multiply that out because it's the quantity squared, so we're going to, oops. It's a binomial times a binomial. So we will get sine squared of x, oops, one thing there, negative sine times cosine of x, another negative sine times cosine of x, so we'll have negative 2 sine of x cosine of x, and then we multiply these, we'll get positive cosine squared of x. All right, so if we rearrange a little, we can have sine squared x plus cosine squared of x, which we know equals 1. That's our Pythagorean identity. And then we know that this, and we come back to our formulas, is the formula for the sine of 2x. The sine of 2x always equals 2 times the sine of x times the cosine of x. So anytime we see 2 times the sine of x cosine of x, we can replace it with the sine of 2 times x. And that's exactly what we were supposed to get. That's the equivalency of the right-hand side. All right, so let's go ahead and rewrite these as sines and cosines. So we'll write this as cosine of x over sine of x minus sine of x over cosine of x. And then we'll have cosine of x over sine of x plus sine of x over cosine of x. And then let's fraction bust. We don't want all those fractions within the fraction, so our least common multiple of the denominators would be sine of x cosine of x. So we're going to multiply top and bottom by that. Remember, it's a whole value, so it's not going to change denominators. It's going to knock those denominators out. So that we would have sine of x cosine squared of x over sine of x minus sine squared x cosine x over cosine of x. And then we'll have sine of x cosine squared of x over sine of x plus sine squared x cosine of x over cosine of x. So here the sines divide out, here the cosines divide out, sines divide out here, cosines divide out here. So that we have cosine squared x minus sine squared x over cosine squared x plus sine squared x. Well, here in the numerator, cosine squared x minus sine squared x, let's go back and take a look at our formulas. That is the cosine of 2x. Cosine of 2x equals cosine squared x minus sine squared x. So we can replace the numerator with cosine of 2x. And then the thing is, the denominator, we've got cosine squared x plus sine squared of x, which we know equals 1. So we really just have cosine of 2x as we were supposed to get. All right, on the next one, so let's rewrite this as 2 over the sine of 2x. We know that the sine of 2x is 2 times the sine of x cosine of x. So the 2's will divide out, and we just have 1 over the sine of x cosine of x. And since I know where we're headed, I need 2 sines in the denominator and 1 in the top so that I can get a tangent. I'm going to scale this up. I'm going to try multiplying top and bottom by sine of x. So that I have sine of x over sine squared x cosine of x. And I could split that up and write it as 1 over sine squared of x times sine of x over cosine of x. And if I do that, 1 over sine squared is the cosecant squared of x, and sine of x divided by cosine of x is the tangent of x. So we get what we had on that right-hand side. All right, one more here. So we've got the sine of 3x. So we're going to have to use a sum formula here. We've got to split this up. The highest we can go is 2x. So we can do sine of 2x plus x. Now remember, our sum formula tells us we do the sine of the first thing times the cosine of the second thing plus the cosine of the first thing times the sine of the second thing. And then we can use our double angle formula. So we know sine of 2x is 2 times the sine of x cosine of x, and then that's being multiplied by the cosine of x. And we know cosine of 2x, we've got some different options. But if I look here, I'm going to end up with a cosine squared. So I want to go with the option that gives me a cosine squared. So let's go back and remind ourselves about that one. So, you know what, there's one more we can do that we didn't even write out yet, so let's go ahead and write it out. So because it's cosine squared x minus sine squared x, we can replace sine squared. We know sine squared equals 1 minus cosine squared x. And so if we distribute, we've got cosine squared x minus 1 plus cosine squared x. And so if we combine like terms, we have 2 cosine squared x minus 1. So that's yet another way we can express that cosine of 2 theta, and that's the one we want, 2 cosine squared x minus 1. And that's being multiplied by the sine of x. Okay, so if we simplify, we've got 2 times the sine of x times the cosine squared of x. And here I've got to distribute the sine to both. I'll have 2 cosine squared x. Well, let me write it in the same order I have the other one. So let's write it 2 times the sine of x times cosine squared of x minus the sine of x. So these are like terms. These are both sine of x cosine squared. So I can go ahead and add them together. 2 of them plus 2 more gives me 4 of them. So we have 4 times the sine of x cosine squared of x. And then we still have minus the sine of x. And then I can realize, oh, GCF, both of these have a sine of x. So we divide out the sine of x as your GCF, and we have sine of x times 4 cosine squared x minus 1, which is exactly what we had on the right-hand side. And we've proven our identity.